Okay. We are discussing rational functions, right?
Yes.
Rational functions. In this, I taught you about one thing, that is type 1. Type 1. What is the type 1? Type 1 we discussed. That is, this function is a rational function means polynomial by polynomial. This is constant polynomial. Constant polynomial by linear or linear by linear. This both are same model, linear by linear. So you know how to find out domain. Anyway, you know how to find out domain. Okay. So range, how to find out range also we discussed. So we discussed an example and we are discussing one more example. Let's take f of x equal to 3 minus x by 2x plus 3. This is the example. Let's discuss about this. So for this, domain is very clear. Domain is all real numbers but not minus 3 by 2, because it minus 3 by 2 denominator is not defined. That is it. So now here we'll find the range. We'll find out the range. What is the range? It's very simple. I told you to write the reverse function. So first what you should do, you assume f of x is y. Instead of writing f of x, see, writing f of x is little complicated than writing y. Simply you can write y. Instead of writing f of x all the time, you can write y. Because when we draw the graph, we take f of x on y axis. Therefore, we can write instead of f of x, we can always write y. Okay, either y or f of x is same. Okay, that means we are taking this. This is called dependent variable. X is called dependent variable or input. F of x is called, x is called independent variable. X is independent variable. In function, x is independent variable. Okay, y depends on x. If you give the value for x, then you will get the value for y. Y is dependent variable. Y is dependent variable because y depends on x value. As you give x value, then we get the value of y. So instead of writing f of x, always you can write y. So now you write y equal 3 minus x by 2x plus 3 and then find out the value of x in terms of y. That's what we discussed last time. 2yx plus 3y equal to 3 minus x. This x you bring this side. 2yx plus x equal to 3 minus 3y. Here x, if you take common, 3 minus 3y, by this becomes 2y plus 1. So now this is what is x. Then now here x is real. Understand? Now x is real. We know x is here real, but not minus 3 by 2. So obviously what will happen here is this x is real means this should be real. If this has to be real means 2y plus 1. This should not be equal to 0. That means y should not be equal to minus 1 by 2. That means y can be any real number, but not minus 1 by 2. This is how you have to find out the range for this kind of questions. What is this kind of question? Either constant by linear function or linear function by linear or linear polynomial by linear polynomial. This is what we discussed last time.
Yes, sir.
Now we'll discuss next type 2. Type 2 has this, that is either constant polynomial by quadratic. See, quadratic. I'll write quadratic. Quadratic. Quadratic I'll write as q. Constant by quadratic. Quadratic. Write qc. Quadratic will write qc. Or linear by quadratic, or even quadratic by quadratic. One quadratic is there, either in the numerator or denominator, one quadratic is there, or even quadratic by linear also, quadratic by linear also, same method. Okay, this is very rarely asked, but this you should have knowledge of this. So one or two will do. Okay, let's take an example. Simple example. We'll take few examples. One. Example one. X by x square plus 1. Simple example I'm taking. Second. Here we'll take 2 by x square minus 1. Next 3. Here let's take next some 2x plus 3. This is linear by quadratic. Okay, anyway, 2x plus 3 by x square minus x plus 1. Next 4. X square plus 1 by x plus 1. Let's take like this. Okay, all the here whatever I wrote above, all those 4 I covered. Okay, we are what we are finding? Domain and range. Domain anyway we know. For first question, solution, first question, domain. Domain is all real numbers because denominator cannot be 0 for any x value. For all x values, for all real values of x can take all real values because denominator cannot be 0 because x square plus 1 is always positive. So there is no problem. So now we will find range. For range, what you should do? So here we can have, here we have shortcut also, but anyway, I'm going to tell you the standard process. What is the standard process? So range procedure. What is the procedure to find the range? Process to find the range. Let same y equal to x by x square plus 1. Okay, that implies now what you get here is yx square plus y equal to x. The next yx square minus x plus y equal to 0. Okay, now how to find out x value here? X, how do you find? How do you find x? You know how do you find x? This is quadratic equation.
Getting the middle term.
Yes. How do you find x? Therefore, we'll use formula method. Quadratic equation, we'll use formula method. What is that formula method? X.
Minus b under
Very
root.
good. Right. Minus b is minus 1. Plus or minus. Minus b plus or minus under root of b square. B square is minus 1 square. B square minus 4. A is y. C is also y. By 2a. 2 into y. Hope you understand this, right? X value. Same.
Yeah.
Previous type 1 also we have found x, right, in terms of y. X we found. Here also we are finding x. Because we know x is a real number. Now this has to be real number. Now what is that x here? Now x is here like this. X is like this. X is, what is x value here? 1 plus or minus under root of 1 minus 4y square by 2y. Yes. Now here x is a real number. Now you see x is real number. X is real number means this whole thing is real number. This whole thing has to be always real. Yes or no? X is real means this is real. When this is real, that implies x real. X real means what? 1 plus or minus this whole thing is real number. This whole thing is real means whatever is there in the root 1 minus 4y square must be greater than or equal to 0, number 1. And also number 2 is y must be not equal to 0. Because y is there in the denominator. Two conditions. Y is there in the denominator. Y should not be 0. If y is 0, then x is not defined. Okay, x should be real number. X we should get real number. If x we should get x real number means y should not be 0. Y is 0 not defined. X will not be defined. That's one thing. Okay. And
y is equal to 0 will be a common condition for all the problems of this sort, constant by quadratic or linear by quadratic equation.
No, it's not like that. It depends on the question. In this case, it is like that. But in all the we cannot say in all cases. In this case, we got a simple thing is that we have to find out the value of x. If you find the value of x, then you will understand. Find the value of x, then you will understand. Here thing is under root is there. Whenever you got under root here, under root is there. If it is less than 0, if it is less than 0, it's going to be imaginary. But x is real. No? That doesn't work. Therefore, 1 minus 4y square greater than or equal to 0. I think this is clear. Here in this case, y is not equal to 0. In other cases, y may not be the same. Y here in this, y is not equal to 0. In some other cases, y minus 1 we may get. That y minus 1 is not equal to, y is not equal to 1 also. You may, that possibility is there. Thing is that depending on question we should do.
Yes.
Okay. So here, how do you solve this? I will tell you. This is this 4y square you have to send that side. Okay. 4y square if you send that side, it's going to be less than or equal to 1. And y not equal to 0. So here what you get, y square is less than or equal to 1 by 4. And y not equal to 1, 0. Two things are. Y square is less than or equal to 1 by 4 means here you need some y square. How do you solve y square is less than or equal to 1 by 4 and y not equal to 0? These two things are. Y square is here. I will give you example. This is important. See, let's say here let y x square or y square. Y square is less than or equal to 4. Understand this. Here 1 by 4 is there. Wantedly I am taking 4. Otherwise we will take some other number. Less than or equal to 9. Let's say. How do you solve? How do you solve? Solution. Solution means value of y satisfying this. See now, how do you solve this like this? This is y value. Otherwise, what we will do is take this x. Same thing. X square is less than or equal to 10. You have to solve. This is x values we are taking on x axis. Now this is, let's say, 0. 0 is satisfying or not?
Satisfying.
Very good. 1 is satisfying or not?
Satisfying.
2 also satisfying, 3 also satisfying, but 4 is not satisfying. Till 3 it is satisfying. Yes or no?
Yes, sir.
You take 1.1, you take 0.999, you take 1.1, you take 2.2, you take whatever you take, it will satisfy. Till 3 it will satisfy. 3 also will satisfy. 3 square is equal to 9. So even if you take minus 1, it will satisfy, minus 2 it will satisfy, minus 3 it will satisfy. So that means what here? This is going to satisfy minus 3 to 3. All the numbers from minus 3 to 3 will satisfy. Therefore, for this solution is what you know. X belongs to minus 3 to 3. You should understand this point. Okay. Now I am giving now one rule we are taking. Rule or form. A rule or formula. Rule or we'll take formula. Rule or formula. What is the formula? X square is less than or equal to a square. Let's take a square. Here in this case 3 square. X square is less than or equal to a square. Or even you can take, if you want, you can take a also. There's no problem. We'll take it, no problem. X square is less than or equal to a. But a should be positive number. Then x belongs to minus root a to plus root a. Hope you understand. Lies between the roots. Less than or equal to 9 means lies between the roots. What are the roots? Plus or minus 3. What are the roots here? Plus or minus root a. This is the formula number 1. Next, formula number 2. X square is greater than or equal to a, where a is greater than 0. Here, x does not lie between the roots. X belongs to minus infinity to plus minus infinity to minus a. Minus root a. Union root a to infinity. I will tell you this. I will tell you this one. Less than or equal to 1 by 4 means lies between the roots. What are the roots here? Yeah, I will tell you here also. We'll take the same like that one. Here 0. 0 is satisfying. Yeah, satisfying, but 0, it cannot, y cannot be 0. So here we'll take 1 by 4, we'll take wantedly. Here 1 by 2 I will take. Then I will take 1 I am taking here. Here I am taking minus 1. Here we'll take 1 by 2. Minus 1 by 2 will take it. 1 by 4 will take it also. Minus 1 by 2. If you see 0, anyway, 0, but 1 by, till 1 by 2 it will satisfy. 1 by 2 it will satisfy. 1 by 4 it will satisfy. These all will satisfy. But 0 is not satisfying. I'm putting 0 mark here. That is, it's not satisfying. So therefore, y lies between the roots. See, less than means lies between the roots. What are the roots here? Minus 1 by 2 to 1 by 2. But one problem is there. What is that? Cannot be 0. If it is 0, then x cannot be real number. That's what we discussed. This way you can write, or you can write like this. Y belongs to minus 1 by 2 to 0.
Open bracket.
Then 0 to, yeah, 1 by 2. Open bracket. So 0 we are eliminating. Removing it.
Yes, sir.
So this is somewhat different model. Okay, I have done this one. I have done this one. This one you can do yourself. That's not a problem.
Should I do it now?
Now, this all third one I will do. Third one I will show you. Yes, tell me, Harshika, what you are saying?
Sir, you asked me to do the second one on my own, right? I was just asking if I should do it right now.
No, not right now. Later you can do and tell me tomorrow.
Okay, sir.
Third one we'll do now. Third one, okay, you can try third one now. I will do, and you can 2x plus 3 by x square minus x plus 1. See, I am giving this randomly. That's why you may get answer, some weird answer you may get. 2x plus 3 by x square minus x plus 1. Let y equal to 2x plus 3 by x square minus x plus 1. That's the question, I think. 2x plus 3 by x square minus x plus 1. Like this. So here, this is yx square minus yx plus y equal to 2x plus 3. This is yx square minus yx minus 2x plus y minus 3 equal to 0. Here, this is one term and this is another. So I write y into x square minus y plus 2 if I take into x plus this is y minus 3. So this is a x square. This is bx. This is c. Now if we compare with this, then x equal to what? Minus b. That minus b is y plus 2. Minus b plus or minus 100 from b square. Y plus b square minus 4a. C is y minus by 2a. 2 into y. What is x here? Once we will see x. What is x here? Here x square domain will find x square minus x plus 1. X square minus x plus 1 should not be 0. But this will not be 0. This is 0 for imaginary because this cannot be 0. Yes, always x belongs to R. I think this will never be 0. Why? When x equal to 1 plus or minus 100, b square minus 4ac is by 2a. That means what? For this x value, this will be 0, but the imaginary roots. Imaginary root. That means what? X, if you take any real number, this will not be 0. Therefore, domain is all real numbers. This is what is domain. So for range, what you should do?
So we need to simplify that.
We need not simplify. We can take this one like this. So here for range, what you should do for range? Here y plus 2 whole square. Y plus 2 whole square minus, you take the inside 4 minus 4y square plus 12y. This should be greater than 0. Yes or no? Whatever is there under root, this should be greater than 0. So that is the thing. Here, if you take this, no, y square plus 4y plus 4 minus 4y square, you can send 4y square that side. 4y square minus 12y, we can send that side, because anyway this y square is this side. If you take this also that side, then 3y square, then minus 16y plus 4 less than or equal to 0. Here you can find out the roots. I told you already that I have taken randomly. That's the reason you may get some. Here less than means lies between the roots. We have to find out the roots, and then 4 3 is 12. So roots are some weird, some roots you get, because some complicated roots you get. Y equal to, here what you get is 16 plus or minus b plus or minus under root of b square minus 4 is 256 minus. These are the roots, lies between the roots you get.
Yes, sir. Sir, I have a doubt in one of the questions that sir gave in the worksheet.
Okay. Tell me.
So should I? Oh, yeah. Okay.
Yes, tell me.
Says f of x is equal to under root x square minus 3.
Okay.
Sir, I got the domain. We only have to find the domain for this.
Okay.
And I got the domain as minus infinity to under root minus 3 union root 3 to infinity.
Okay.
I don't know if it's right.
Correct. Correct one.
Okay, sir.
All right. So what shall we do? What shall we do is here y equal to 0, y is 0, y is 0, y is 0, then x is 0, no, x is 0, y is 0. Yeah. Okay. Yeah. Okay. All right. Okay. What shall we do is, see, here we'll here one point I'll make you clear, that thing is here, this is range means what? Y value. Range means Y value. So what is the value of Y, right? All the Y values constitute range. All the X value will constitute domain. Yes or no?
Yes, sir.
Okay, right. So here in this case, yeah, here one thing is there here. Here Y value is 0. Let's say Y is not equal to 0. I said, because by seeing this, I told Y is not equal to 0, but Y is 0, what will happen? If Y is 0, then what will happen? X by x square plus 1 you will get. Yes or no?
Yes, sir.
That implies x equal to 0 you get, right? Yes or no?
Yes, sir.
So that means when x is 0, y you are getting 0. And that means what? Y value 0 is possible. Your thing is inverse function is not defined. That inverse function we did not discuss. That's why you may not know. This is inverse function we are finding. So y is, so here only thing is this only. That means what? 1 minus 4y square. This is 1 minus 4y square is greater than or equal to 0. This one thing is enough. Here this is not required. Actually, if you write this one, you have to check y not equal to 0 we are putting, but y equal to 0, if you put, what you will get? If y equal to 0, then x becomes 0. That's all. That means what? When x is 0, that means here what is here domain? Domain is all real numbers. That means what? X takes all real values. When x is 0, then y is 0. That means y value we are getting 0 also. So therefore, one correction here, that is y can be 0 also. This is not correct. So y can be 0 also. So small correction here. So yeah, y can be 0 also. No problem. Yeah, hope you understand. If you don't understand, you can ask me. So here, domain is all real numbers. That means x takes all real values. That means including 0. When x is 0, y value becomes 0. Here I said y cannot be 0 because we found inverse function. Reverse we found. But here, if y is 0, we have to check here. If y is 0, then what will happen? X is 0. That's what. If y is 0, if y is 0, like this, if y is 0, then x becomes 0. There is no problem. So therefore, this is not a problem. So that's what we need to check here. Here also same thing like that only. Next example also same thing like that only. If y is 0, there here also there is no problem. Y is 0, then x is minus 3 by 2. For x value minus 3 by 2, y becomes 0. So therefore here also there is no problem. Therefore you should take here also you should check only one condition. Okay, here I told no this one no I randomly picked randomly I wrote problems here 2, 3, 4 like that. That is the reason you may have some problem in finding this. Some complicated roots you may get, but I will give you some problems which you will get means properly roots and all will get properly. We'll discuss that one. Okay, right. So this is second model. Hope you understand. This is second model. First model is what? Constant by linear or linear by linear. Highest is linear. Here, but here highest is quadratic. Here quadratic by quadratic also you may have. Okay. So therefore here what I will do is I will tell you one thing now. I will tell you common condition. I will tell you common condition. What is it? Common condition. Common condition is delta. Discriminant. Delta is discriminant. Discriminant. Okay, that is D. No, you say discriminant D must be greater than or equal to 0. Why? Because in every question you get the same. Here, first question also what you got? This is discriminant, right? This is for this question. This is a discriminant. Discriminant must be greater than or equal to 0. For the second question also what is this? This is what is discriminant. This discriminant is greater than or equal to 0. For range, discriminant is greater than or equal to 0. So that I will tell you one example. I will tell you one example. I will tell you. Okay, f of x equal to range we need to find range of x square plus x plus 1 by x square minus x plus 1. Okay, we have to find out range for this. What I will do is let's say y equal to, let's say this is y, say y. Okay, then what will happen? Yx square minus yx plus 1 into y equal to x square plus x plus 1. Okay, this y into here y minus 1 into x square, right? Y minus 1 into x square. Okay, this x square if I bring here, this x square will bring here, so x square. Here minus y minus 1, that is y plus 1 times x plus y minus 1. This is equal to 0. Here what I am saying is here x is real. X is all real numbers. So x is real. When x is real means what? That implies x is real means root. X means x values are roots. Roots are real. Roots are real. Roots are real means delta greater than or equal to 0. For this equation, delta greater than or equal to 0. Did you understand this? X is real. X value is what? If you find the value of x, that is called root, right? Solution or root, right? That roots are real. X is real means roots are real. Roots are real means delta greater than or equal to 0, which I showed in two examples we saw, right? Here, under root, whatever comes, that is called discriminant. That discriminant must be greater than or equal to 0. Directly we can do, instead of writing x value, x equal to minus b plus or minus under root of b square minus 4ac. After writing all that also, what you should do? B square minus delta, that is b square minus 4ac greater than or equal to 0 you should do after doing all that also. So first only we can do that. What is that minus b? This is what is minus b. B square is y plus 1 whole square. B square minus 4a is y minus 1. 4ac is what? Again y minus 1. This is greater than or equal to 0.
Yes.
Oh, wow, you got it, I think. So now what you get here? Y plus 1 whole square. So this is going to be 4 times y square. If you take this one, no? Y minus 1 whole square. Y square minus 2y plus 1. If I take that side, minus this is y square plus 2y plus 1. This is less than or equal to 0 because both we brought this side. 4 times y square minus 1 whole square. That is this minus. This is y plus 1 whole square is y square. So here 4y square plus y minus y square is 3y square. Here minus 4 2s are 8. 8 minus 2 minus 10. 10y. This is 4. This is minus 1. That is 3. Less than or equal to 0. Okay. Now I will tell you. This one I will tell you. So 3y square minus 10y plus 3 less than or equal to 0. So here like less than means lies between the roots. I will show you. Here anyway we will find the roots here. 3y square minus this is 3 3 is the 9. 9y minus y plus 3 less than or equal to 0. 3y if I take common, y minus 3. Minus 1 if I take common, y minus 3 less than or equal to 0. Here y minus 3 if I take 3y minus 1 less than or equal to 0. Less than means lies between the roots. Now if we take this is 1 by 3. This is, let's say this is 1 by 3. Let's say this is 3. Okay. Now if you take more than 3, this all what you get is positive you get. Now this one in this range what you get? In this range you take this is 1. This is 1. This is what is? Let's take this is 2. Let's take this is 0. Now in this what you get? Positive you get. But in this you get negative values you get in this. If you want you can substitute 1. If you substitute satisfying or not. Please substitute 1 and check satisfying or not. If you substitute 1, is it negative or not? Less than 0 or not?
It's less than 0.
1 if you substitute minus 2 into 2. If you substitute 1 also, 2 also up to 3. So less than means lies between the roots. What are the roots now? Y belongs to 1 by 3 to 3. This I will explain. This I will explain. 4 formulae are there. I will explain that.
Yes, sir. So what formula
I'm explaining. I'm going to explain you. Just so this is, I think you see, this is the final thing I told you, that instead of discriminant greater than or equal to 0, if you use directly, that's enough. Okay. This process you understood?
Yes.
You can type 2, you should apply discriminant greater than or equal to 0. First you should assume as y, then you get quadratic equation in x. Quadratic equation in x, then you apply this one. Okay, even if you x equal to minus b plus or minus, even if you do that also, discriminant greater than or equal to 0, you should apply. Instead of doing all that, you can do directly like this. So now in this case, you are going to get a problem here. Okay, now I am going to explain 4 formulae. Number 1, how to solve x minus 1 into x minus 3 less than or equal to 0. Next, okay, this is first. Okay, we will do this one. Now this is same as this one, you know?
Yes, sir.
The same thing only. Here y minus 3 here, same. 3y minus 1. If you take, yeah, y minus, yeah, here if you take 3 common, what you get? 3 into y minus 1 by 3. 3 if you take y minus 1 by 3, this is y minus 3 less than or equal to 0. If you take 3 that side also, you get y minus 1 by 3 into y minus 3. But just for understanding easily, I am taking this example. Okay, is that okay?
Yes, sir.
Yeah. So how to solve this? You see, how do you solve this? By graphical method. This is x-axis. Okay. Otherwise, here you take y-axis. In this case, if it is x is there, x-axis. Otherwise, y means on y-axis. So here, this is 0, this is 1, and this is 2, and this is 3. Okay.
Yes.
Yeah, okay. Now, thing is that you substitute the values more than 3. That means 3.1 you substitute. If you substitute 3.1, 3.1 or more than 3, if you substitute, this is positive, yes or?
Yes, sir.
X values more than 3 will give you positive. This will not satisfy. Inequation will not be satisfied. Is that okay? So, yes. Then if you apply these values, less than 3 if you apply, so then what will happen? Less than 3 if you apply, what will happen?
It satisfies the equation.
Yes, if it will satisfy the equation. So till 1 it will satisfy, 1 also will satisfy. So if you take 1, 2, 3, then what will happen? More than 1 means this is positive. Less than 3, na? More than 1 but less than 3. This is negative. Positive into negative, negative. It will satisfy. This is negative. This is first positive. This is negative. Again, less than 1 means this is negative, negative, and this is also negative. Okay, negative into negative, positive. This becomes positive. Like this only you should apply. So, or if you want a case 1, you should take like this. Case 1, what is that? X greater than 3. X greater than 3 will give you what? X minus 1 is, X minus 1 is, you have to explain all this, not required, I think. X minus is greater than 0. And X minus 3 is also greater than 0. That implies X minus 1 into X minus 3 is greater than 0. So that is positive. Now, this all, if X is greater than 0, this is all positive. This is not required for us. So case 2 is what? X lies between greater than 1, less than 3. So that means greater than 1 is what? X minus 1 is greater than 0. X minus 3 is less than 0. And X minus 1 into X minus 3 is less than 0. We have to write all this, but not required. Just by seeing here only, you can understand, right? This is okay.
Yes.
No? So X
Yes, sir.
equal to 1 and X equal to 3. That's also okay. Greater than or equal to 0, less than or equal to 0, less than 2. Therefore, this is a region. Therefore, X belongs to, lies between the roots. What are the roots here? 1, 3. X belongs, X 1, 2, 3. So that is what is the thing. So therefore, what we can establish here is formula 1 is X minus alpha into X minus beta less than or equal to 0 implies and implied X lies between the roots alpha and beta. Number 1. Number 2, X minus alpha into X minus beta is less than 0 means what, you know? Here alpha less than beta. Alpha is a lesser root, beta is a greater root. Less than means what? Only open bracket, because alpha and beta are not included. Okay?
Yes, sir.
Here only less than is there. Equal to is not there means 1 and 3 also will not satisfy.
Yes, sir.
Okay, next. Here x minus alpha into x minus beta greater than or equal to 0 implies x does not belong to alpha and beta. Does not belong to alpha and beta means you are telling x belongs to minus infinity to alpha. Okay, minus infinity to alpha. Yeah, open bracket. This is open bracket because alpha beta is included. Alpha union beta to infinity. Okay, this I will tell you why. 4. X minus alpha into x minus beta greater than 0 implies x belongs to minus infinity to alpha union beta to infinity. Okay, this we'll discuss. Example now. X minus 1 into x minus 5, let's say, is greater than 0. Greater than 0 means this is x-axis. This is 1 and this is, that's 1. And this is 5. More than 5. Now only I told more than 5 means what? More than 5. More than 5 is this is positive. More than 5 means this is positive. Positive into positive, positive. That means if you take x value greater than 5, then expression is positive. So between 5 and 1, this is negative, like previous only. Again here, this is positive. Because one is negative, another is positive. Greater than 1 means this is positive. Less than 5 means this is negative. Positive into negative, negative. Therefore, this is going to be negative. And this is again positive. So because one less than 1 means negative. Negative into negative, negative and negative, positive. So this, therefore, x does not belong to minus infinity to, does not lie between the roots. Does not lie between the roots. That means x belongs to minus infinity to alpha union beta to infinity.
Yes, sir.
Okay, that is the reason here I gave this 4 formulae. Here equal to means including, includes. Equal to means includes. That is equation, that the equation. That's,
Sir, I have a small doubt.
yes.
So in the third formula, x belongs to minus infinity to alpha. Why is it a closed bracket?
Close bracket, why? Because equal to is there, no? So here, for example, here,
Understood. Because it, yes.
yeah, here x minus 1 into x minus 5 greater than or equal to 0, meaning this implies what, x minus 1 into x minus 5 equal to 0, or x minus 1 into x minus 5 is greater than 0. This, for this or this, anything it can, that is x equal to 1 or 5, 1 or 5, or x belongs, x greater than means what, this thing. This means what, 1 and 5 is included like that. X can be equal to 1 and 5 also.
Yes, sir.
Okay, so this is here, yeah, here equal to, if you keep, then here you will get closed, you get. This is also included. This is also included. If you keep equal to, then this becomes closed bracket. Okay, this 4 you should learn.
Yes, sir.
Okay, then we'll go to next one. We'll go to next part. Okay, this what we discussed is range of rational function we discussed. Then we'll get irrational function. What is irrational function? What is irrational function? You know this. If it is not rational, it's called irrational. Simple. Okay, irrational function is some square root, cube root. A root is there. If it is not rational, or okay, simply uh, if a function is not rational, but algebraic. If a function is not rational but algebraic. Algebraic means it is in terms of x. Any function in terms of x is algebraic function. Okay, algebraic function. Any function in terms of only x is algebraic function. This algebraic function means trigonometric ratios and logarithms and trigonometric functions, exponential functions are not included in this. So, for example, like this, square root of x square minus 3, you said, or x minus 3, or square root of 3 minus x, or cube root of 5 minus x square, whatever it is, so on. These square roots are there. Roots are there. When roots are included, then it is not rational function. It becomes irrational function. Square root is there. Many things are comma x to the power of 3 by 2 minus x plus 2. This is not a rational function. F of x equal. This is not a rational because o to the power of 3 by 2 is there. If this is not rational function, this automatically this becomes irrational function. Very simple. Any algebraic function which is not rational, that becomes irrational.
Yes.
Polynomial function also you can call rational. Polynomial function means what? Rational function means polynomial by polynomial. Okay, rational function is polynomial by polynomial. So numerator is a polynomial and denominator is a constant. That becomes what? Rational and also polynomial. So rational function includes polynomial functions. That you should understand. Okay, rational. Now irrational functions. For this irrational function, what you should know is how to find out domain and range. First, we will find domain. Domain of rational function. This already you know, rational function. Okay. Domain of rational function, you know. How do you find? So example, f of x equal to, now like this you said. So we'll take x square minus 9. Second example, we'll take under root of 9 minus x square. Third example, not 9. We'll take 19 minus x square. Third example we'll take is x minus 3. Fourth example, okay, domain and range both we can find, I think. Under root of x square minus 3x plus 2. Okay, yeah, 2. We'll take like this. Okay, next, number 5. Okay, we'll write more, but first we'll do this. Anyway, this one, very simple. X square minus 9 is greater than or equal to 0. Like previously, we had a formula that is x minus 3 into x plus 3 into x minus 3. So greater than or equal to 0 lies between the roots. What are the roots here? Simply you can write like this. This is minus 3, this is 3. This is 0. If you take more than 3, positive into positive, positive. So all the x values greater than 3 are satisfying this. And here also this is satisfying. This is also satisfying. Minus 3 means what? This is negative. This is also negative. This is minus 4 satisfying. Minus 5 satisfying. So therefore x belongs to, I think this is minus infinity to minus 3 closed union 3 to infinity.
Yes, sir.
This no? I think this 1 2 also right?
Yes, sir.
3 also right?
Yes, sir.
4 also
Yes, sir. That's also just getting the middle comment.
Okay, right. So we have formula that same like that only. But here fifth one, just I am writing like this, x square minus 9. Sixth one, f of x equal to 1 by under root of 5 minus x square. 7, f of x equal to under root 1 by under root of x minus 3. What is fifth one is denominator. Since it is denominator and root, x square minus 9 is greater than 0, it cannot be 0. Yes or no, you tell me.
Yes, sir.
Because it is denominator, it cannot be 0 also. It is numerator, it can be 0. But it's denominator, it can't be 0 also. So x square minus 9 is just simply greater than 0. So that is x plus 3 into x minus 3, that is greater than 0. That is does not lie between the roots. X down to minus infinity to minus 3 union 3 to infinity. That's the difference. There included, here it's included. Minus 3 and 3 included, because numerator it can be 0 also. But when it's in denominator, it cannot be 0. Second one also.
Second one is also the same.
Yeah, second one is what? 5 minus x square is less than 0. X square minus 5 is, if you multiply with minus, then sign will reverse. Yes or no? Here minus 5 is less than 0. Minus of minus 5 is greater than 0. That means when you multiply with negative number, when you multiply minus, then sign will reverse. The sign will reverse. The sign will reverse. If you multiply with negative, this minus 5 plus x square, that becomes greater than 0. So here x plus root 5 into x minus root 5 is greater than 0. Greater than means does not lie between the roots. X belongs to minus infinity. You are telling this one actually. You asked question this one. Because it's in denominator, we are not including, otherwise you should include the roots also. So like that. Hope you understand. Like that only you can do this. Finding domain, I think you must have already learned. Domain of rational functions. I'm sorry, what is that? Irrational, I'm sorry. Irrational, yeah. Irrational functions is what? And domain of irrational function, then we will find range. Next class tomorrow we'll find range of irrational function. By tomorrow we'll finish.
Yes, sir.
By tomorrow we'll finish, but anyway, I'll send some worksheet on functions.
Okay.
I think tomorrow we have modulus function, greatest integer function, signum function. These three we have. Okay, limits you finished. Huh? What did you tell about limits?
We didn't finish limits.
Okay. Then functions we'll finish by tomorrow. We'll finish functions. And today we'll try to send a worksheet also, which includes these all model problems. That worksheet you can do. So in school, what is happening in school? Statistics, they have finished statistics.
No, sir, we're still doing statistics.
Yeah,
We
yeah,
finished.
yeah. Statistics, dispersion, no? Measures of dispersion, right?
Yes, sir.
Yes, measures of dispersion. Okay, okay. Okay, then you can that only. You have economics. In economics, anyway, you have. Oh,
Statistics is not very hard. We already finished everything in economics.
economics, you already finished. Who is teaching you economics?
So Deepa, ma'am.
BPharm. Okay. Mm-hmm. Devasena ma'am is not there, I think, right?
No, sir.
Okay. All right. Thank you. So that's all I think, right?
Yes, sir. So after,
Uh,
can we do complex numbers?
yes. Okay. We'll do complex numbers.
Yes, sir.
We'll have revision of complex numbers after this.
Yes, sir.
Okay. I'll send anyway worksheet. I'll send today for this. In the school, I think they must have given some worksheet, right, on relations and functions.
Yes, sir. Sir gave a worksheet in school.
Okay, that also you can finish. Once you can revise all this, since you have the statistics already easy, you can do this relations and functions. And if you have any doubts in worksheet or textbook, you can ask me. Once you, okay, what you do is I will not send worksheet, but you do textbook, everything you finish in textbook, and then whatever doubts you have in textbook, we will discuss in the next class, because tomorrow we'll finish. Tomorrow we'll have class, right? Wednesday.
Yes, sir.
We'll have class.
I understand.
So we'll finish functions, and whatever doubts you have, we'll finish textbook, and then we'll give worksheet. Okay.
Okay, sir.
Tell Ashita also to complete. And if she has doubts tomorrow, she should come with doubts. I'll send this class to her.
Okay, sir.
Yeah. Okay. Thank you.
Thank you, sir.